Hello pre-calculus students, and welcome to the video on some hints for solving problems that deal with angles and that deal with trig ratios of double angles, half angles, and power reducing. And if you're in Mr. Wen's math class, this is section 5.4, and this is number 9 in one of the exercises. And we're asked to solve for x in the interval 0 to 2 pi. And as always, when you're solving these problems, you should think about what makes these problems difficult so that you can be able to decipher how to break it down. Okay. And one of the issues here is that the inputs are different and the functions are different. So different inputs. One of them has 2x, the other one only has x. And then different functions. I have sine and I have tangent. So this is gonna cause me a little bit of a problem, but it won't be too difficult. So one of the things that I can do first is I'm gonna deal with the different inputs for a moment here. And I'm gonna use sine of double angle. So this becomes 2 sine x cosine x. And the rest of the function is still intact, minus tangent of x, whole thing equals 0. And it would seem that at this point I've made things even more difficult. I used to have sine and tangent, now I have sine, cosine, and tangent. But one thing to remember is that tangent is just sine over cosine. So what I'm going to do next here is separate this into sine over cosine. And then I'm trying to subtract two fractions, so I need a common denominator, finding the LCD. So basically I'm going to multiply this left term here by cosine x over cosine x. And so now that I have sort of everything together, what I'm going to do is combine these two. So now I have cosine x 2 times 2 sine x cosine x, and that's one term, that's this whole term right here, minus sine x, and then the entire thing divided by cosine x. And all of this is set equal to 0. Well, now I've got what looks to be quite a bit of a mess, but it shouldn't be too bad because what I can do next is I'm going to multiply both sides by cosine. Okay? So I'm going to multiply both sides of this equation by cosine. In effect, so if I multiply the left side here by cosine, the denominator goes away. If I multiply the right side by cosine, well, nothing happens because this is still 0. So now I have, I'm going to simplify this. I'm going to have cosine x times 2 times sine x times cosine x minus sine equals 0. And so right here, there's some work that I can do to kind of simplify everything. Okay, so I'm going to this whole thing here is going to turn into 2 sine cosine squared minus sine of x equals 0. And at this point, you should probably hit pause and try to finish this problem yourself. And actually, you can hit pause at any point you want. But again, the sooner you can do this and kind of wrestle with this on your own, the more success you will experience in the long run. Okay, okay. So I'm going to continue now, and one of the things I'm going to do here is just factor out a sign. When I have a common term here and here, I'm going to factor a sign out of here. And this is going to give me sine x. What I have remaining is 2 cosine squared minus 1 equals 0. Then use the zero product property and split these two. So I have sine x equals 0. 2 cosine squared x minus 1 equals 0. Well, on the unit circle, sine is 0 at this point and at this point. So I know x equals 0 and x equals pi. And the original problem is asking for this interval, so I don't have to add 2 pi n to it. Now on this side, I'm going to solve for cosine squared here, so I get cosine squared equals 1/2. Take the square root of both sides, so I get cosine equals plus or minus the square root of 1/2, which is incidentally square root of 2 over 2. Okay? So I have now cosine x equals root 2 over 2, and cosine x equals negative root 2 over 2. Okay. So if I check the unit circle, it's basically all of these points here that are a quarter of the way around. Okay. Let me use a different color here, so I'm not writing, since things are getting kind of cluttered already. So this is one set of answers. Well, this set of answers here, this point here is pi over 4. This point here is 3 pi over 4. This one right here is 5 pi over 4. And this one down here is 7 pi over 4. And those are going to be all of my answers. And I apologize for having to squeeze this in, but I sort of ran out of room here. And that's the final answer to this problem. So it's a fairly challenging problem here. But you can see that there's a logical progression from beginning to end. And the key part is really what happens at the beginning, which is being able to use the double angle identity here for sine of 2x. Thank you for watching. Have a wonderful day. And again, if you struggle with this, ask your teacher for help whenever it is that you see him or her.